Okay, good morning, students. Today is September the 30th. It's 7:11, so we're going to start in this class, finite elements. After we did this adjustments in our flow chart in the naval engineering program, we lost the class which presented programming, algorithms and applications and things like that. But we are convinced that computer programming is something which is very important. So in this class, we're going to ask you to remember what you did in your two previous classes, computer fundamentals and numerical analysis. And since probably those two classes you took them several semesters ago, I think it's a good idea if we spend one session before the classes start to review basic things about how to start a program and things like that. Okay, that's the objective of this session. Okay, we are not going to show you something that you don't know. This is just to remind you how to do it. Some people last year, when I taught this class last year, reported that they spent so many hours just trying to get the things to work. And after that, the algorithms that we need to develop are very simple. But at the beginning, it was very difficult for them just trying to remember, how did I do that? How did I do this? So that's the idea behind this session, okay? So we're recording, so we're going to post this session in the Teams platform. And in this session today, we're going to take advantage of the time that Genesis Loyola has. So she's going to present it. That's all for me. Go on, Genesis, you are the one who is going to present this. Before that, Genesis, please remember that you have to post in the chat the material that you are going to present.
That's what I'm trying, but I can't.
You can't?
I don't have the option of share any document.
No, in the chat? Or let's do this, okay? Let's send it to me, and I will send it. I will put it in the in the general, or send it to somebody. For example, send it to Alison Pinkai. She appears in the first place in this list.
Okay.
And then Pinkai, you can send it to Gutenberg, Jimenez, Guerrero, and then you can see the list of the people who are here, so you can send it to all of them, okay? Including me, please.
I send it to Carolina Gutenberg.
Okay, good.
Bye.
Carolina Gutenberg, please resend it to your classmates. Please, Genesis, I need the material also. Don't forget me.
Yeah, later.
Good morning. Sorry, I don't understand the question.
No, what we're saying is that Genesis sent you the material for this presentation. And what I want from you is to resend that to your classmates, because we have problems trying to put it in the chat.
Okay.
Thank you. Or if you could put it in the chat, that would be better. Okay, go on, Genesis.
Well, this, as the doctor said, this is a brief introduction to Python programming. It's a tool that everyone needs to relearn from the basic cycle. And for the final element course, students should be able to develop those skills, develop schemes or code representation as flowcharts, and design codes and programs to analyze cases that couldn't be realized manually. That's because sometimes we are going to manage a large group of data that couldn't be processed manually. So programming is the best option. I'm going to present in a general way some instructions and operations that are going to do in this course. As I mentioned, the flowchart. For the programming sections, the libraries used, how to define variables and to create algorithms with iterative cycles, and the evaluation of functions. These are some optional guidances. There are some reference books that you can find related to how to construct these flowcharts. For example, this red book is a high school book to teach students how to create flowcharts from zero. And there are other...
Just a second. Are you showing something on the screen?
Yeah, I said that I'm sharing the screen.
People, can you see the screen?
Yes.
Yes, doctor.
Oh shoot. What did I do? Okay, go on.
Well, I said that this red book is an example of a high school book that teaches students how to create flowcharts from zero. And I have other virtual references, as this booklet made by engineer Luis Rodriguez in Spal. If you have this presentation, you can access to these books on the link here. I see this subject finite elements last year, so I suggest to use this app creatively to create flowcharts. It's very easy because this app is very intuitive and helps students how to develop some skills in flowcharts. And also you can access it from this link. Here you can download the latest version of Python. And you can access to this link. And these are some environments that sometimes are commonly used. I suggest to use the one from Python. This is the one that I used when I was a student, and maybe the doctor will indicate you that use the same to check the homework. These are the most used libraries. NumPy for list and array, math for arithmetical operation and trigonometric functions, matplotlib for graphs, 2 and 3D graphs, and the last three, OpenPy, Excel, Excel Writer, and SciPy, are for edition and opening of files, TXT file or CSV files. To define a variable, we should know that there are basic data structures like integer, float, strings, and complex. So to assign a variable or define a system, we could do it directly. And if the variable is an operation that involves another variable, that should be previously defined. For example, here, x equal to 3, and the operation that involves the previous variable defined x. Algorithms. An algorithm is an organized description of instructions that must be carried out in order to solve a problem in a finite time. The structure includes a data entry and the results output, but in the middle is a group of instructions that will perform the transformation of the data. In general, these algorithms are blocks that includes conditionals that are logical operators among other variables. This is an example. This is an example of a flowchart that starts open a TXT file, splitting the lines and set the information into lists using a conditional. If the data is in a row and is not a string, then it's added to a certain list, and then the program saves the results as a TXT file. This is just the first section because This example is from my midterm project of finite elements, so it's very large. This is the code from the first section of this flowchart. So the example is very complete. And it's the same, import libraries, and then import the txt file, define all variables, then create a loop of conditions, assign the elements of the results to the list that we previously defined, and then we save all the results in a file, and it's the end of our program. Well, the end of the first section of our program. As I mentioned in the agenda, we are going to review briefly the function definition. So these are the most commonly used functions, or the most basic functions, the delta Dirac and step function. You can define it like this, or there are other ways, but these are the most, it's more clearly to see in this way. You define it as the def function, but there are other ways to define it as lambda function. And this is the structure in the flowchart. You can define these functions in the flowchart in another block, and not in the same block as the main flowchart. You can define in a separate way. This is a practical problem that you can use. You can see how Python works. We have this configuration of the bin is commonly seen in ship structure, and this is the deflection function of this problem. I solved this problem in two ways. The first one is that as I don't find just a function that defines this step function, I split it into two intervals, from 0 to half length of the beam, and for the half length of the beam to the end. And then I start like this. I input the applied force and the length beam. I define this, and then I set the deflection function per interval, because I split it into two. And then I derive the deflection function 1, 2, and 3 times. And then, as the bending moment and shear force are the second and third derivative respectively, I assign those results into lists, because I define the bending moment list as an empty list and the shear force as the same way. And after I define those lists, I save the results of the deflection functions that I have in this section, and I create a loop to save all the results per interval, from 0 to half of the length of the beam, and then for the half length of the beam to the end. I'm going to show it how I create this process in the environment that I suggest to use, because it's very easy to see how it works. This is the environment of Python with no external idle, or as PyCharm or Atom or Microsoft Visual Studio.
Just a second, Hennis, can you hear me?
Yes.
Okay, why don't you ask if everybody has been able to open or to download the Python tools in their computers, or they have it, so they can follow your explanation, your example. Go on.
Are you able to download the Python, or you already have it from previous courses, because maybe you need it for another programmation course?
Let's go one by one. Miss Pinkai, Miss Pinkai, can you tell us something about, did you have the Python on your computer?
Yes, I have it.
Okay, Gutenberg.
Yes, doctor.
Okay, Miss Sayo,
Yes, I have it.
Mr. Jimenez,
Yeah, I have, doctor.
you have it? Okay, good. Mr. Guerrero? Your microphone is off, Guerrero. Can you hear us? Can you hear us, Mr. Guerrero?
Yes, Mr.
Do you have the Python? Good morning. Do you have the Python on your computer? The Python package?
Yes, but now I'm not in my computer. I'm in my
Okay.
cell phone.
Okay. Okay. Good. Good. At least you are following the explanation. Mr. Carrion. Carrion.
Good morning, doctor. Yes, I have Python.
Okay. Good. Mr. Diaz.
Yes, doctor. Good morning.
Good morning. Do you have it?
Yes.
Okay, good. Miss Vega, Liliana Vega,
Yes, doctor.
do you have it? Okay, good. Miss Lopez, Miss Lopez,
Yes, I have it, doctor.
good. Mr. Zambrano, Mr.
Good morning,
Zambrano,
doctor. Yes, I do.
good. Miss Freire,
Yes, yes, doctor.
do you have it? Good. Mr. Sanchez,
Good morning, doctor. Yes, I have it.
okay, good. Mr. Arias, Mr. Arias,
Good morning, doctor.
okay. Do you have it? So everybody has it. Good. Go on, Genesis, with the explanation, with the example.
Yeah. Well, for this example, we are going to use 3 libraries that I mentioned before. As we are using this environment, we need to download it from the system symbol. So we put on our keyboard MCD, and we have this window, and we set easily pip install the first one, the first library, NumPy. As I already have it, so the requirement is already satisfied. Second library that we are going to need is SciPy.
SciPy.
I mistake it. It's simply. As I said, I already have it, so the requirement is satisfied again. And the third and last library is IP install matplotlib, because we need the exercise consists in get the graphs of the shear force and bending moment of this problem that we are giving only the deflection function. So for the graph, we are going to install matplotlib for 2D and 3D graphs.
Just a second. Ask if everybody has these libraries in their systems.
Students, as maybe you are working on other kind of environments and this is really new for you. Are you follow my explanation and install those libraries, the ones who are working in their computer now?
People, let's go the other way, because I think mostly you have worked lately in this with this Python programming. Does everybody has any problem trying to load these libraries? Go on, Genesis. People? Raise your hand if you have problems. Please, raise your hand if you have problems. It looks like everybody has their libraries, right? Okay, go on, Genesis.
Well, a new file, an empty file. Oh. So this is the class exercise. And save it as this. Save as class exercise. As I said, we are going to import the libraries. Import NumPy and the other ones, SymPy and Matplotlib. And as I said, the first steps are we are going to input the or define the applied force and the length of the beam. I define it as 200 newtons to force and a length beam of 6 meters. As I said, the first this method implies that I split the function into intervals. So the first interval is from 0 to half of the beam, and is this section. I define this function as y1. It's from 0 to half of the beam included. And the second interval, this one, is from the half of the beam to the total length. And this section includes the step function coefficient, which is this. So the function that I define as y2 is from half of the beam to the total length. Now we are going to differentiate those functions per interval. So the first part consists on differentiation of the first function, the first derivative of the first function, and so on for the bending moment and shear force. Are you following me, students? Doctor?
Yes.
I have problems because I try to use another screen, and now I cannot follow both. So I'm just listening. But people, do you have any problems? Are you following Genesis' explanation, please?
Yes.
Well, for the second part, I'm going to differentiate the second function because it's the function for the second interval from half of the beam to the total length. So this is the derivative of the second function, and then the second order derivative and the third one for the bending moment and shear force. I defined 3 empty lists for the x coordinates, for the shear force and the bending moment, because those lists are going to be filled with the results that we are going to obtain by loops on one conditional. I have to do this because I split the function into two, so I have to work in 2 different intervals, from 0 to half of the beam, and then for the rest. So as our half beam is 3 meters, we define it from 0 to 4. And then I save the results for the shear force and bending moment for this interval. And then for the second interval, I'm going to define it from 3 to 7 and make the same process. Save the results of shear force and bending moment for this interval. And those results are added to the empty list that I defined at the beginning of these loops.
Thanks. Go on.
As I said, the code is up to here because the last part is just the graph section. So you have to run it.
Just a second. In the first range, in the first interval, I goes from 0 to 4.
Yeah.
And in the
Because-
second, you go from 3 to 7. You shouldn't go from 4 to 7?
It's not, because if I do this, I have a problem, because in 3, in the half of the being, we have a singularity.
But you could
Well-
evaluate, in that point, you could evaluate.
It's because of this graph. If
I know. But the thing is that if I go from 0 to 4, it's like going above 3, and you start from 3.
It's not above 3.
Not?
It's not. No, because when you said for E in range from 0 to 3, it only takes 0, 1, 2, and 3, up to 3.
It doesn't
why
take the
I
last
said-
value? Okay,
Don't-
now that's
That's
fine.
why I said 3 to 7, because it's 3, 4, and 6. It
3,
doesn't
4,
take the
5, and
last
6. Okay, good. Yeah, thank you. That's different. It's different language. I work with, in my language, when I say from 0 to 4, it goes from 0 to 4.
No.
Here
it's
you
from
said from 0 to 4, but it understands 0 to 3. Okay, good.
I believe that you are mistaken, because I repeat the 3 here, and no, the 3 that I repeat here is because of this step
Yeah.
function.
Yeah, it makes sense.
As this code is not very efficient, I don't have an dx that could fulfill this singularity. That's why I repeat the number. This is for the shear force, and this is the bending moment graphs.
Wow.
As I said, the last part of this code is plotting. So this library, matplotlib,
But
help us to plot these 2D graphs. What happened, doctor?
yeah, but that's wrong, because that's the negative of the shear force.
Oh.
Yeah, you're missing one symbol, right? Yeah. When you
Yeah.
define this third derivative, yeah, that's negative. There you go. There
I
you go.
don't know if this is working correctly, or I'm going to have a problem.
That's that's correct, right? Yeah,
Yeah.
that's correct.
Now.
That's correct.
This is an inefficient code. I discovered another way to do this, all these calculations.
Just a second. Ask if everybody's following you.
Students, everybody following me or understand my explanation how this code works?
People, if you have a question, please raise your hand or something like that. Is everybody following the explanation? No, there's no questions. Okay, go on.
As I said, this code is not efficient, so I find a way. I find a way to do it more shortly and in just one function, and I make the derivatives directly. So this is the method that I discovered yesterday, because I didn't do it when I were in the finite element course, because I didn't know that this function exists. I found it in a forums of the university of the FIEC. They defined this function NP because it's NumPy, piecewise, because this is the step function for them. There is the conditional 1, 0, and you can just write the function in one line and not split into intervals. The difference is that you have to define the interval of work. So it's from 0 to the length of the bin. And this is the thing that I said previously. Now you can define a dx. that is working on the interval previously defined. And the procedure is not similar to the last code. You can derivate directly. The bending moment is the second derivative, and the shear force is the third derivative of this deflection function. Is directly only 2 lines, and then you don't need any lists, or you don't need to fill those lists with a loop. This directly, you can plot it directly from this one, and you have the same results. Oh, but it lasts a little bit. I have a little problems in this part, because as I defined the function just in one line, it considers the singularity that occurs at 3, at half of the beam. So that's why I defined this dx. I try to do it a little more small, but the program it takes so much time. So that's the minimum that I could use. And with that small value, I get these problems in the singularity, but it works because we know that this is the value. This is only a jump that occurs and we don't know why, but we're going to see as if it doesn't exist. Are you following me, doctor, students? Do you have any questions?
People, do you have any questions?
I have a question.
In what part? Or in
I
what
don't
code?
understand. I don't understand why in the second code.
In the second code, this pilot. Yeah.
I don't understand why you put in the x 0.001. I don't understand that part.
Oh, yeah. It's because this way of derivation, it's just a line for plots, right? I use it for plots, and you evaluate this function in a certain value. So that's why I define an x range from the limits that I define a to b, and this uses the dx because it's like initial, end, and the step, this paso in Spanish. So when you evaluate this function, this derivative, you also have to include the same step that you use here.
Mm.
And that's why I said that we have this problem here in the singularity. Even if I use a small dx, I have this problem. If I include, if this is smaller,
Larger.
it's larger, sorry. More smaller, more larger.
This is larger.
Yeah, this is that we are going to our result. Can you see it?
So
the singularity is gone, but it's not completely correct because we have this.
it should be vertical.
It should be vertical, and now we have like a slope.
Yeah. Yeah, that's related to the dx. Yeah.
There is another question because it was a good.
Miss Ayo, are you solved with this issue, your question?
Yes, thank you.
Okay, okay.
These are some optional guidances that I suggest to use. Most of us use this one on the basic cycle for numerical analysis and Python programming. Those are in my OneDrive, but I share it with you. If you have this presentation, you can access it to the link. And as I mentioned, I discovered some new functions that I didn't use it for my finite element course in this page of forums of the university.
Oh man. Maybe we should tell the people who develop this block that we are using them, because that makes it's a good feedback for them that they're producing something which is useful. So people, Genesis, please send them a note from outside telling them that it is useful, this function that you just described, this step function.
Yeah.
Okay.
There is no more questions.
Is there any other question, people? No? Okay, so I think that this is all for today. So I hope you enjoyed this, and for me it's quite difficult because the way we develop programming using Visual Fortran it's different. This is different, and it's much more efficient, definitely. I mean, the way you define things are in Fortran, we usually would need more instructions to complete this assignment. And well, that's it. Is there anything else, people? Is there anything else? Or in this case, we will just say goodbye and that's it? No questions? Okay, if you have further questions later on, you can send email messages to Genesis, okay? She will be assistant for this class, and she can try to help you out with these things. Okay, bye-bye now.